full connection to everything else we've been talking about, which is hopefully not too surprising once we talk about it. So what we did a few years ago, it's been about 3 years now, I think. We'll be able to tell by look at how old Max is. We went to the feed store and picked up our chicken flock. Ben says on a lot with at least, I think it's 6,000 square feet of room, you are allowed to have up to 4 chickens, up to 4 laying hens. Let me back up to that last picture so you can see how we get them. So here's Max feeding them, loving them. There's the box they come in, a little Happy Meal box they come in. It's adorable. You go to the store and you go to the store and they put in a little box and you buy the big thing of food and some feeders and some bedding. The whole deal costs about like 20 bucks for these 4 little birds, which then create massive amounts of poop for the next 16 years of their lives, which is fantastic because it's great fertilizer for your garden. So it's kind of a nice symbiotic relationship. Plus they lay eggs for you. Maybe, right? Because why is it maybe? Because you're not guaranteed they're girls. That's the catch, right? You go in there, they're day olds. They call them day olds. So they go to the store, they're 1 day old, just hatched. And I remember walking into the store, and Max picked these 4 girls up. That's Marge, that's Nancy, that's Mary, and you can't see Bertha. There's Bertha right there. There's Bertha, named after our grandmothers. And we said, okay, so they're called pullets. When they're girls, they're called pullets. I forget what the boys are called. The baby boys. But they weren't selling those in the store. They were only selling baby pullets. And I asked the guy at the store, I'm like, what's a pullet? He said, oh, it's a sexed female. Like, it's a sexed female. What does that mean? And he said, well, it's been identified as a female. And I look at this thing in my hand. It's the size of a piece of Easter candy. Like, how the hell do you know it's female? I try to like lift the skirt up. Like, how do you know it's female? Like, oh, we have this process. I'm like, okay, this thing is still as big as my thumb. How do you know if you're right? And he told me this. He told me this. They are 90% right when they identify a chick. Okay, is this similar to what you guys have heard as far as what's out there? So I was saying yes, 90%. I've never been told a different number than 90% as far as accuracy of sexing chicks. All right, so I look at the box. Max has a little Happy Meal box with 4 little, and they're peeping, they're very cute. And I said, that means there's a 1/3 chance I got a rooster in here. And the guy looks at me, like I got 3 heads, and how the hell do you know that? And then I sat down and gave him a 5-minute introduction of what we're going to be doing today. And he was like, that's amazing. He was totally blown away by that. Totally blown away by the fact that if you have a box of 4 little baby pullets in it, there's a 1 in 3 chance you've got a rooster in it. Which means on average, over time, if I keep sending Max into the store and buying 4 chicks, 1 out of 3 of those times, I'm going to have a rooster in there somewhere. And he was just blown away by that. He said, oh my God. And then when I explained it to him, he's like, oh, that's kind of cool. I'm like, yes, and hopefully you guys will also think it's kind of cool as well as we work through it. Because it is tied back, believe it or not, to the mathematics we've been studying for the past 2 weeks. It's just the next logical extension of it. I remember years ago I used to play this disc tossing game in class, which is the also tied, but this is way more applicable, I think, to more people. I mean, carnivals coming through Bend versus chickens coming through Bend. I think it makes more sense about chickens because backyard chickening seems to be a bigger deal than it used to be. So anyway, think about this. There were hundreds of those things in the store when we went to get them, and I'm sure there will be again when we go, I think tonight or tomorrow night, whenever we go after swimming lessons. So hundreds of chicks, and Max walks in and grabs one of them, right? Puts it in the box, and he picked one of each. He picked this is. I actually took this offline. I didn't take any pictures of them in the bins when we bought them, which is kind of unfortunate. But hundreds of chickens in the store, hundreds of peeping little, and there's a turkey on the end too, which are also very cute. So the question I had is: suppose Max goes in and he grabs. Well, let me ask some questions. I got some questions. Would you call this independent or dependent sampling? Think back to your last project. I like those terms from that project. I want to keep referring back to them. So, what do you think? Independent or dependent? In other words, without replacement, or excuse me, with replacement or without replacement? Without, really, because what do we do with chicks? We brought them home, David. Yes, we took them home with us. I mean, if you think about it, independent sampling would mean that I have to go in, grab the chick, put it in the box, and then say, okay, Max, put it back. And he would be pissed. That's what we want eggs, right? The whole point is we want eggs. So now the question is, it definitely is this kind of sampling because you're bringing them home. But I want to establish one thing right now. The math, as you guys remember, is easier with this kind of sampling. It's much harder with this kind of sampling because you have to do that whole down by one, down by one, down by one, right? My question is, can we cheat the little tiniest bit and treat it as independent sampling, even though it's really dependent sampling? Yes. Now, so let's make sure we understand why we can. There were, let's say there's 500 chicks in the store, just because that's a pretty good approximation. It's probably closer to 1,000, I think, when we went in there, because it was just chaos and it was awesome. Max reaches in, grabs a chick, pulls it out. What's the chance it's a girl?
90%.
Oh, careful. Forget my box for a second. He grabs one chick and picks it up. What's the chance it's a girl?
90%.
90%. That's what I've been told every single time. He puts it in the box, put the box aside. He goes back in and grabs a chick. What's the chance it's a girl?
90%.
If we treat it as independent, it's 90%, yes? But if we treat it as dependent, don't we have to decrease both things by one because he took the girl out? You see what I'm getting at here, friends? Okay, so he puts, we'll come back to that in a second.
So it'd be 89%.
Well, it might be. It depends how many chicks. It depends if how many chicks were in the bins. We'll come back to that too, if that's okay, Pat. So put that one aside. Now go back in. Give me two answers as to the chance this one's a girl.
Either 90 or...
You can treat it as 90 if it's independent or whatever's left. So let's address that issue right now, okay? Let's address that issue right now because we have to use this logic from here on out. And anytime you guys read the news, this logic also works. So I want you to buy it before we go any further. I'm going to mute the screen. Okay, so we bought 4 girls. Well, we bought 4 chicks. And we want to see if they're all girls. Yes, that's the whole point. We want to see if they're all girls. So if we want to do that, let's use our... Let me zoom in a little bit. Okay. What's the chance? Let's go independent first. Independent first. What's the chance the first one's a girl? And we said it was 90%. And that's assuming that he's exactly correct in telling me it's 90%, and we walk in before 8 chicks have been taken out. Think about it that way, which is kind of a little bit of an inconceivably lie too. So 0.9. Now, if we're assuming independence, what's the chance the next one is also a girl? 0.9, right? So if I buy a second one, the chance it's also going to be a girl is 0.9 times 0.9. Is that correct? 0.9 times, hopefully that makes sense. How about the next one? Now, do you see why I'm multiplying and not adding? Because what did Max do? He picked up one bird.
Did he put it back?
Well, we're treating it as if he did mathematically here, but he picked up one bird.
Put it in the box.
And then he picked up another one, put it in the box.
Put it in the box.
And then he picked up a third. Good, Ariel, thank you for that. Yeah, when you can see yourself saying and, it means you're multiplying. And hopefully you realize it gets harder and harder and harder to get all girls the more you pull out of the bins. Because every time you grab a bird, there's a chance it's a boy. So the more pulls, the more chance there's a boy in there somewhere. This is measuring it on how much there is. And then finally, he picked one more, right? Times 0.9.
This is all independent.
This is all treated as independent. I want to come back to dependent, Pat, and put our minds at ease. But first, I want to compare it to the independent. So, friends, that's the chance that all of the birds in the box are female. About 66%. Remember what I told the guy at the desk? What's the chance? What's the chance I got a rooster in the box? 1 in 3, which is roughly the opposite, the complement of this. Now, I sure as hell couldn't get it down to this in my head. What I did was I did 0.9 times 0.9 is 0.81, threw the 1 away. 0.8 times 0.8 is 0.64, and I said that's about 2/3. Which means I got about a 2/3 chance that we've got all hens in the box. The other 1/3 has to have at least one boy in there somewhere. And that's the part he was like, that's really cool. So, regardless, there it is. What I want to do now is I want to go back. And reanalyze this more realistically, which is if I grab the bird and take it out of rotation. Does that make sense? Because this is assuming, as Nick correctly pointed out, putting the bird back in, yes? Putting the bird back in. So what if we don't? Now, mathematically, this is the math I did in my head. Let's see how well the proper, if you will, math holds up. Okay, so it's a 90% chance of a female, yeah? So if I go in there, I'm going to assume that 90% is at work right now. Let's assume there's 500 birds in the bins, yeah? So how many females are there in the bin?
Well, you can't tell because you don't.
90% of them.
Yeah.
450.
450 of them out of the 500 are female. Now, Ryan, you're correct in saying you can't tell exactly because you don't know how many have been drawn so
Well,
far.
I get what you're saying. I'm just saying you
can't tell with any
can't
pure
tell.
certainty. So I have when he tells me 90% and I'm looking at the birds, I'm like, okay, 90% of these girls.
Yeah.
So assuming Max is drawing randomly, which again I have no idea if he is or not, the first bird that comes out is going to be a female 450 out of 500 times. 50 of the 500 or 10% are going to be roosters. He grabs it, throws it in the box. Then he goes back in. What's the chance the next one is female?
449.
449 out of 499, right? Because there's a bird gone now out of the bins. You see what I'm getting at, friends? So now it's 449. Put that in parentheses.
This is dependent, right?
Say that again? This is definitely dependent on what actually happened, Ryan. Yes, thank you, sir. This is what actually happened, obviously, because we took the birds home. And they're still sitting in my backyard not laying eggs right now because they're old now. Times, hence why we're going back to buy more. 448 out of 4. Yeah, I can't kill them because we named them. I can't make soup out of them. Hi, Mary. I can't cut your head off now.
So what happens to the old birds?
They just keep eating our food and pooping and running around. Not laying eggs. Once in a blue moon, I get an egg in the duck house. I'm like, oh, there's Marge laid an egg. Great. 448 out of 498. Oop, that's one out of 4.
Okay, where'd the 450 come from?
90% of the 500. 450. And then last but not least, 447 out of 497, yeah? Okay. Check it out. Yeah, good. David and Monica, you guys did the exact same thing. You went like this. You said, huh? How much of a difference is there between the actual probability and the independent probability? And the answer is not much. That's why if you're drawing a very small amount from a very large amount, even though it's not technically correct to treat it as independent, you can, because the mathematics is way easier to crunch, and you get arguably the same answer. Is that a fair assumption? Now, what's a great quote? Oh, Veronica, go ahead.
So the parameters are a small amount from a large amount.
Thank you for saying that again. The question is a small amount from a large amount. Because suppose it was a very small amount you were drawing from. Suppose there were only 10 chicks in the bin, yeah? 10 chicks in the bin. Then it would look like this. 9 out of 10 times 8 out of 9 times 7 out of 8, right? Am I doing this right?
Yeah.
Times 6 out of 7, yeah?
This reminds
We're down now 6% from what it should be. Now we're getting it's still fairly close, but we're getting too far away. It's no longer the 100th place where it's differing. It's now moved over to the 10th place. And the smaller it gets, the worse it gets. Carly?
Where do you draw the line between a small sample?
Nobody agrees wholeheartedly, but when you're in the hundreds and thousands of a population, you're drawing a small amount from that, you can treat it. There is an old, you hear, Carly's got the next good question is, where's the line in the sand? Here's one that I generally use. If your sample is less than 5% of your population, go ahead and do it. If your sample is less than 5% of your population, then go ahead and do it. That's my line in the sand. It seems to work pretty well. I've run Excel simulations that show pretty good agreement between the two. Now, you got to understand the importance of what Veronica and Carly just put forth. It will never be the same. It is wrong to do it the original way that we did it. Because it's not sampling without replacement, it's sampling with replacement. Excuse me, it's not sampling with replacement, it's sampling without replacement. But the thing is, if you're only differing in the 10,000th of a percentage place, you can ignore that and get the answers you need realistically without that. Is that fair? Call it a great question, and there's no hard and fast rule for it. But basically, I live by, if it's less than 5% of your population, you're golden. This is why Gallup can do it when they do their polling. Gallup will usually survey about 2,000 voting Americans, of which there are like 100 million. So you grab 2,000 out of 100 million, you're like, okay, that's less than 5%. You can go get 100,000 and you'd be golden. They won't do that because it costs too much. So great question, both of you guys. Great question and great restatement of the problem. In all of these problems we're going to be looking at with the binomial, it's always sampling without replacement. But you can treat it as if it worked. as if it weren't. You can treat it as if you're putting them back in, because the mathematics is close enough. Ask me questions about that. That's a fine point I wanted to get out of the way right now, because as we go along, you're going to be thinking about that the whole time. Wait a minute, it can't be 90% every time. It depends on what you pull. And if we got a boy at the first, we still have to decrease the denominator, but the numerator's not going to decrease, because you're pulling a boy out. Don't worry about any of that. We're going to assume that with replacement is a legitimate way mathematically of looking at the results. Not 100% correct, but it's definitely correct enough to get any kind of analysis done.
So what you're saying is we don't have to worry about boys, because that was going to be my question. What if
We do. I'm not saying don't worry about boys. I'm saying this is the chance we get all girls. I want to go back in and analyze all the chances about getting boys. And I also want to figure out, on average, how many girls can I expect out of how many. If I buy N birds, how many girls can I expect out of those N? No, I'm not saying don't worry about boys. I'm saying let's not worry about how to count the birds right now. The point of today is to actually fill the board with the distributions of the flocks. Yeah, we're not worried about them at this moment, but we do have to concern ourselves, because that's the first thing I told the guy. There's a 1 in 3 chance there's a rooster in this box, right?
But if you pull a rooster, then it limits the other chance.
It does. So what's the likelihood of pulling a rooster? That's my question. You never know. You never know. You don't know until they actually mature enough. I mean, I thought Mary was a rooster for the longest damn time, because she was in the back. I'm like, oh, shit, got a rooster. Here comes a soup. Here comes Craigslist. But it was just, Mary's just loud. It's just the way she is. They're all laying eggs. So they're all girls. We got all girls. So we fell into this 2/3 of the time where we get through. I mean, that's the obvious. You're twice as likely to get all girls as you are to not get all girls. But it's still a roll of the dice, right? It's still a roll of the dice. So I'm not saying ignore the boys. I'm saying let's agree on how we can count the birds first, then talk about the girls and the boys. Is that fair? Is that fair, Pat?
Yeah.
Great question. All the questions you guys have right now. I just spent 15 minutes on that, and I apologize. It might seem like a drawn-out 15 minutes, but it's important, because if we can establish that right now, then the mathematics becomes much, much more trivial at this point. Interestingly enough, I was approached by an old student a couple years ago, very confrontationally via email, which unfortunately happens a lot. You know you're wrong about your chickens. I'm like, okay, tell me how I'm wrong about the chickens. And she said, there's a chance. I heard it on the radio. I'm like, okay. There's a chance that a chick is actually born with both genders, male and female. I'm like, really? I thought that was very interesting, so I Googled it, and I found a couple sources that actually say 1 in 10,000 chicks are born boy and girl. And I said, that's freaking rad. That is freaking rad. So I redid all the math with that third possibility. What I did was, instead of 90-10, I did 89.995 and 9.995, and then whatever was left over became the other case. And I ran the numbers, and it ends up being only different by about 1 in 50,000 on average over time. But she's correct. But again, it's one of those things. Yeah, you're correct, but we can ignore that case because it doesn't change the overriding numbers except in the 10,000th decimal place. You see what I'm getting at? That's kind of the logic of what we're talking about here. Why we can ignore that dependence and treat it as independent. Veronica, go ahead.
So would that be like an outlier to us?
Yes.
The fact that
Very much an outlier, 1 in 10,000. Yeah. Anything under 5% is generally considered an outlier event. I want to talk about that a lot today, actually, thank you. But yeah, that's so rare that it doesn't affect the rest of it. Now, I didn't throw it out right away. I ran the math first, and I made the distribution first. It was actually cool. It's called a trinomial distribution. Totally cool. But it didn't affect anything, so I sent her the results back. I was like, this is a great question. Here are my results. I haven't heard back from her. So, one of those unfortunate things. Fire up a nasty email and then never hear from anybody again. But it was fun math to do. I saw a hand go up.
Yeah.
Pat.
So that's like all generalities, you know, you're dealing with like, okay, with the chances and the percentages.
Yes!
But really, it doesn't really matter. Unless you get a rooster, and then you got a problem.
Well, it depends on how you define a problem. For us, because we want eggs, it's a problem.
Right.
Some people think they want roosters because they think, for example, they think that chickens will only lay eggs with a rooster around, which is not true. They're going to lay eggs regardless. You only need a rooster if you want more chickens. So, it depends on what you mean by problem. See, for us, it's like, yeah, and I know if we keep sending Max into that store, and he keeps buying 4 birds at a time every 3 years, we're going to get a boy. It's at some point, if that 90% is correct. If that 90% is correct. It's all hinging on that 90% that he told me.
So you do this rotation every 3 years?
We only had to do it once before. We started having chickens 3 years ago.
Okay.
Now that they slowed down their laying quite a bit, we're going to go 3 more. So now we have to see. I don't know how long the 4 older girls are going to live. I mean, I have no friggin' idea. They could live like 15 years old.
Yeah.
And they love our backyard, full of bugs and ponds and lizards. I saw them get a frog once. It was disgusting. Little velociraptors they are. Ever since I watched Jurassic Park years ago and I saw the whole tie between the birds and the dinosaurs, I watched them hunt. It's terrifying. They can run around. I used to think it was so cute watching a chicken run, running with their little skirts lifted up. Now all I see is that velociraptor running toward me. It's this big, of course. And they catch a lizard, rip its head off. I'm like, oh my god. Yeah. Anyway, I have a yard full of them. Within 10 years, I'll have a yard full of freaking retired hens.